Here's problem 2517. A particle charged 40 microcoulombs moves directly toward a second particle charged 80 microcoulombs, which is held in a fixed position. At an instant when the distance between the two particles is 2 meters, the kinetic energy of the moving particle is 16 joules. Determine the distance separating the two particles when the moving particle is momentarily stopped. Alright, so we have a situation here. We got two charges. Let's put them on the x-axis. And let's put the fixed one, which is Q2, at the origin. So that's 80 microcoulombs. And then we'll have Q1 at 2 meters away, 40 microcoulombs. So this distance is 2 meters. We'll call that distance R1. And then it's going to move, eventually it's going to reach some other point, the closest approach, which we'll call R2, our final position. So we're going to have a potential V1 associated with our initial potential position, and then we're going to have a new potential at the new final position, V2. Now we can't use acceleration and kinematics on this because the force of Q2 on Q1 is not constant. It is varying with distance, and hence the acceleration that Q1 goes through is not constant either. So we cannot use kinematics on this. We have to use energy. So we're interested in, we know that V1 is equal to K Q2 over R1, and for that matter V2 is equal to K Q2 over R2. In other words, the potential that charge 1 feels is due to the other charge. And so the change in potential it's going to go through is going to be our final potential minus our initial potential, which is going to be K Q2 over R2 minus K Q2 over R1. Okay? So that's going to be equal to 9 times 10 to the 9 times Q2, which is 80 microcoulombs, times 1 over R2 minus 1 over R1. In other words, the change in potential is going to equal 7.2 times 10 to the 5 times 1 over R2 minus 1 over 2, 1/2. Alright, we want to find R2. We want to use energy. So we know that the change in kinetic energy plus the change in potential energy equals 0. So the change in potential energy is going to equal a negative change in kinetic energy would be the negative of our final kinetic energy, which would be 0 because we stopped, minus our initial kinetic energy, which is, we were told, is 16 joules. So we have a negative negative. This is going to be a plus 16 joules. That is our change in potential energy, and that should be equal to the charge times the change in potential. So we have 16 is equal to the charge, which is 40 microcoulombs. This is charge 1, by the way, times the change in potential produced by the other charge. So we have 40 microcoulombs times the change in potential, which we just found to be 7.2 times 10 to the 5, 1 over R2 minus 1/2. The 10 times 10 to the minus 6 will be 10 to the minus 5, and that will cancel with the 10 to the 5. So right now we have 16 is equal to 4 times 7.2, 1 over R2 minus 1/2. We need to solve this for R2. Let's get rid of a 4 on both sides. And so I have 1 over R2 is equal to 4 divided by 7.2 plus 1/2. And that's equal to 1.055. So R2 would be the inverse of that. So R2 is going to equal 1 over 1.055, and that's equal to 0.947 meters. So that's our answer. It will stop when it gets to 0.947 meters away from the second charge.